Welcome to Fixing Bugs and Stuff, and we're going to start getting into the depth of engine building. So this is going to be a series of, we're going to build a 1600 cc engine. It's all going to be stock. I'm going to give you the depth of what I do to these engine cases and what I do to engines, how I build them, that kind of stuff. Kind of like behind the curtains, all the things that I do. And I know this may break the internet. You're going to have a bunch of keyboard warriors or mechanics or engine builders that are going to freak out because I'm going to tell you things that they do and I do. So first, we're going to talk about this case. And this is the case that we're going to be building anyway. This is a B case. I don't know if you can see it there. Let's focus. The B case here, and this is an AE case. Yeah, see it there. It's an AE case. So two different cases, both have dual oil relief. The big difference between the two is you can see, well, one of them is that this doesn't have the boss back here when you put the engine in, and this one does. Also, the difference too is that these holes are smaller for the oil cooler, and these are larger. I can spin this around so you can get a better look. Hold on one second. Okay, see if you can see this side by side. Let's see. You definitely tell that one's bigger than the other, and no big deal. You just have to drill this out larger. Just be careful when you do it. You don't go crazy and drop the drill, and the drill bit will slide and it will crack all this. So anyway, we're going to go through the B case and I'll show you what to check for. And as we go through it, I'll tell you the do's and don'ts. And that's basically it. So let's get into it. Oh, one more thing. I glanced over this real quick. This has a 6mm stud here, where the other one, which is on the ground here, has an 8mm stud for the oil cooler. So this is also important. At this stage, when the case is pretty much bare, I always like to change this out. I'll drill it and rethread it with the proper stud. And I wanted to point that out because I glanced over it. My fault. Number one, what I check first, very first thing I do, I clean off these threaded connections here. I clean these holes off. What I'm checking for is cracks in between this hole and the bore. I've seen that happen a lot. The cracks can go in between the two. Seen that a lot as well. The cracks for this going into the bore. You want to check them all. Just make sure you clean everything that you can so you can check for cracks, especially on this surface on the 1 and 2. The other side will check the same thing for these threaded connections. However, they don't have this threaded connection on the other side, of course. So I'll show you what I'll do. I'll get a stud and I'll put it in here and I'll show you what I check for and how many pounds. This is going to be tedious, but I check all of the bolted connections here using the smaller rod or threaded rod, and I'll stick it in here first. I'll leave 1 to 2 threads max to be exposed here. No problems at all. And if you have the kit that has the deck clearance, has these spacers, and what I'll do is I'll take a washer that I cut like this. You can see it. That way it doesn't damage this surface area here. And I'll stick it on there like that. Take 2 of these. Short one. Washer. Put it on. Tighten it a little bit. Then I'll torque it to spec, which is 23 foot-pounds. Okay, we're right there. If you couldn't reach the foot-pounds, then you know that the thread in here is bad. You're going to have to add inserts. And that's all you have to do. I know it's tedious, but I would do it to everyone. I hate for me to start to build the short block and I go put the heads on, and next you know, these thread rods are pulling out. And that's terrible. That means you have to tear the whole thing down. Take everything out. Then you got to put it on the lathe. I'm sorry, not the lathe, the mill, then add the inserts. And that's a big job. Why not check it out here before you add all of the components like the crankshaft and camshaft and lifters and all that stuff will need to be cleaned and taken out. So this is what I do first. Okay, the next thing I do is I check this oil plate that sits here. Your oil drain is here. Usually I have a plate here to put on top, but I don't have one here. And I'm trying to do this as if your guy's going to do it on your own. If you're waiting for parts to come in and you don't have the plate, you can use a washer and a nut here, and we can test each connection, which I already have. And the best way to do it is you stick the washer on. You don't want to mess up the surface area here. And you want to torque it down to 60 inch-pounds. That's what I have here. Okay, we're already there. No problems. You wouldn't hit, again, just like the other studs, you wouldn't hit 60 inch-pounds if this was cross-threaded or if the threads were bad. It will start to pull out. You will keep torquing and torquing and torquing. Next you know, the whole thing's spinning or it's out of the threaded hole. Okay, this is done. The next thing I check, if I flip it over, I check here where your oil sensor goes, just to make sure that the threads are good in here. Now you visually can see it. If you have an oil sending unit, you can just start threading it on there and see how far it goes in. If it starts to not to go too far, then you're in good shape. If it goes in all the way pretty easily, you may have a problem. You have to drill this out and add a bushing to it. So that can be done as well. Let's see, the next thing I check is number 3. Number 3, in this area, cleaned off, you can see it here, it can crack inside of that groove. There's like a little depth in there. I cleaned that off really well, and I just want to check to make sure it's not cracked in there. I've seen that happen too before. If you know the old high performance engines, they would weld this area here pretty good, just to keep it together so it wouldn't spread or crack. That's why they did it. In this case, it's all stock, so don't need to do that. So I have not put the two halves together. I have not torqued them down just yet. You can, this is the direction, it's up to you what you want to do. You can take a look at your plugs. You have multiple plugs. You can see them here, multiple plugs, and there should be evidence of them leaking if they were popping off. In this case, I don't see that, but I think, I'm not sure yet, we'll go down the road. I'll decide later on, once I check the oil galleys, if I'm going to take these plugs out and just clean the block all the way through, I mean the case all the way through. That may still happen. I'm not sure yet. I'll dig into the inside and I'll make that decision. Also, at this time, you want to check all of your bolted connection here for your tins. Make sure that they're cleared out. Make sure that these are not worn out. It would stink to have the engine and the long block built, and then you go put the tin on and this is not fitting right. And then you got to drill in and basically add a helicoil or a bushing or some sort to hold the tin on. That would stink. Again, anytime you have to do any machining, you want to do it now instead of later on when the block is built. I like to get a brand new screw and just check them all. Just go in here and just add. You can do it by hand, no big deal. If it goes in, great. That one's going in just fine. On the other side, let's check that one out. It goes in just fine. There's multiple places that these are located. especially on the bottom. You see, there's one sticking in here. I'm gonna have to pull out, and there's another one here. It's kind of clogged, so I would have to definitely check that one out. And then on the other side, we have some more here. These are all for your tins. If you're gonna have heater boxes, you're definitely gonna need these. Okay. So the next step, we're gonna move into splitting the case and look into the inside. Okay, the next thing I'm going to check, now the cases are split in half. I want to see if there was any type of, what do you call it, a line bore done on this at all. And I have a gauge for that. I use this. So we're going to use the standard. This one here, we'll check. See if there's any done. A line bore that I can see. And what you're looking for is it'll be very loose in here. As soon as you put it in here, it'll be very loose for the standard. And if it is, then you go to the next one, will be the 0.50 millimeter. And this doesn't sit in there correctly. Let's see if I can get you guys a closer look. Okay, so this is the standard sticking in there. As you can see, it's not much of anything. I can move it back and forth. I hardly can. It's tough to do. But if I put it to the 50, you can definitely see some gap in there. So it's not 50, it's the standard, which we're in good shape here. 50, standard. Yep. So this has not been line bored at all. Also, while we're in here checking, you take your fingernail and see if you can find any raised areas here. And what happens is the actual bearing that sits in here will rock back and forth as you're using the clutch, and the crankshaft is moving back and forth, and it forces this bearing to shift front and back. And what it'll do is it'll wear this side and wear this side and cause a raised edge in the middle. So you can run your fingernail through here to see if there's any raised edges, and I can feel it on that one there. It's hard to see. See the line here, but there's a raised edge. See here in the back, same thing happens too. The bearing shifts back and forth, wears it out on both sides here, and it has a raised edge here as well. I can feel that one. Actually, you can hear it. See this one. This one seems fine, smooth. This one here is fine too. So the way it works is this number 1, number 2, number 3, number 4 main bearing. It's going to be the same on the other side. It should wear the same way. Yeah, I can feel it there. Yeah, definitely feel it there. Feel a little bit there. Not too bad, but nothing on the number 4. And these still have the dowel pins in them, which we'll have to remove later on. And so the next thing, I will check the bores. Now you can, if you don't have a bore gauge for this, you should be able to take a lifter, new lifter, I prefer new, and put it in here and see how well it feels. Make sure you oil it first. Put it in here and move it up and down, see what kind of play that you get. I mean, that's what most mechanics do. Or you can use a bore gauge, and I'll pull one out and I'll show you what I do. I did check it with this, with the bore gauge. They are mostly at their wear limit. They're not beyond that. It doesn't give justification to toss the case. This is still a good case. Even though you're at your wear limit, it is fine. Now, if it was way beyond the wear limit, where I saw grooves in here, then I'll be like, okay, that's way too much. But it's just still a good case. I would still use this. I would still build a nice solid 1600. There's no problems with it. Some would toss it, but I don't. I never had an issue. Let's see what else here. Also, in the process, we're going to be checking cracks. Sometimes there's cracks within here. You got to remember, both cases, they kind of shift back and forth because it's just two halves. There's just two halves, and there's a lot going on There'll be cracks in this area here, within here. I don't see any. Let me wipe this off a little better. And usually it's the middle one. The middle one does the cracks most. And I don't see any here. You guys can take a look. Tell me what you think. This one right here. I don't see anything in that guy here. We'll clean the other side as well. No cracks. Let's see here. We'll check him here. I'll bump you a little bit. I don't see any cracks in there either. Nothing here. Usually there's a crack. Let's check the other one. Let's take a look. I don't see any cracks there either. Nice and clean, no problems. Check the other side. It's always the middle causes the issue. Let's see here. Yeah, no cracks here either. So we're good. We're good. Okay, before we put the two halves together, I do want to talk about this nut area here. This is a longer stud that goes through here. It's threaded, goes all the way through, and then it has a nut here to hold on to this oil pickup tube here, this whole mechanism here. And that's how you get oil fed into the case. This is supposed to be mechanical lock nut here. Not a nylon, it's a mechanical one. Meaning there's no nylon. Nylon will tend to melt, and then if it gets too hot, it will back out. So this is locked in place. Definitely check this before you put the two case halves together, or you forget about it. Definitely check it. A lot of times, some people will double nut it. That will lock it in place. They use Loctite. That will work as well. Make sure it's the oil resistant Loctite. And then the other one is they'll put in a little bead of weld here on the nut so it doesn't back off. I don't like that option because if you need to replace this, that means you have to take the cases apart just in case that the little fillet weld bounces off and gets into your case. So I like the double nut option or the Loctite option. Those are two good options for you. The next major check would be check the webbing in here. I know there's a lot of structural members in here. You see these, what they call gussets in here. It's basically to give strength where it needs to be, especially around where the cylinders sit. You will definitely want to check in here and see if there's any major cracks. Clean it off as best you can. I've already been through here already. Wipe some stuff down. Check. It's not common that you see cracks in there, but you never know how people abuse these engines. Okay, I torqued the two case halves together. This gets torqued to 24 foot-pounds. There is a sequence to when you torque these. Make sure you follow that sequence. That way you don't warp the case. That's the best practice to use. Something else I would like to point out is that when I have the two case halves, I would like to put the nut and washer on these guys here. Because in the end, when you're putting this case together, you want to make sure that these do not pull out. It's imperative. This does help keep the case closed on this bottom half. As you notice up here, all of these here keep the case closed, of course. But then out here, you need these nuts to keep it really closed here. And then, of course, you have this one here to help it from the front, and this one here and the other one. So first, double check these. These usually are the culprits that pull out first. So I'm gonna grab a nut and washer. We'll check these right now. Okay, so these back nuts here, you see them right here. These two here, I'm going to torque down to 14 foot-pounds. So let's do that. Looks good. That looks good. I tightened them up previously, so if these are not being torqued to 14 foot-pounds, they will back off. And then you're gonna have to do something special
in here, you're gonna have to put either heel coil or some kind of bushing in here since it's already been worn out. I'm not talking about the actual threads. These studs will actually pull out. So the next test we're gonna do the light test. That's in the center bearing in here. So we use this light to do the light test. So essentially, the light test is that you're gonna shine a light inside of the case, and what you'll do is you'll shine it in between the spot here. I'll show you here. I'll use this here. You should be able to see that, right? Get you in closer. Yeah. So what we're gonna do, we're gonna shine a light on the inside of the case, right at this seam, right here. So that way, if you see any light, the case is not gonna be usable. I've seen some guys put silicone in here if they see any light, and I've seen it go 50-50. It works great. It doesn't work great. The silicone gets inside. You don't want any silicone inside of the case at all, really. So let's do that right now. I'm gonna put the light inside the case. Tell me if you see anything. You can see it looks pretty dark. I mean, you're gonna see a little light there at the bottom because there is a hole, not a hole, but a groove for some oil, but it's the seam that you're worried about. If you see light going through the actual seam or the two case halves, then that's a problem. Then I'm saying the case is no good. Toss it, use it for a practice case for something else. But in this case, saying case too many times, we're good. We're good here. No problems there. That's a good sign. Okay. I think I did mention that I need to add the stud for this guy. It's missing. I don't know if somebody took it off or it came off. No big deal. It's added. And those threads look good here as well. So it's good. Last thing we're going to do while we're back here, we're going to check the thickness in here. The stock thrust bearing usually is 0.8645. That's what it should be in this thickness right here. I have to check this one. I'm not sure. And what'll happen is that the thrust bearing will beat in and out, in and out, in and out as you're using the clutch, as we talked about before. And I'll measure this, and you'll see. I'll explain a little bit more what the measurement is and why. Because usually on a line board that needs to be done on the case, a thrust cut needs to be done as well. Usually they're hand in hand. It's very rare that you find one that's good enough and that's stock on the thrust. Very rare. But it does happen. So, let's see what this is here. Check this. Yeah, this is showing you here 0.866. So we're over on that. And people wonder why. Well, if it's if the bearing is beating back and forth, shouldn't that area be smaller? What'll happen as the bearing, get a flashlight, as the bearing is moving back and forth, I don't know if you can see it or not, it's hard to tell, it'll start to create a lip here. It'll start to create, as the bearing's moving back and forth, and then the bearing, there's an undercut, and material will tuck up underneath the undercut, and you'll start to get like a ledge or an edge here. I can actually feel it on this one. It should be smooth, but it's not. So essentially, you would think that this area will get smaller, but it does. Yes, it does, but it also creates an edge. That's why I'm getting that larger thrust measurement. But anyway, that's what I checked out so far. If you guys find out that I need to check anything else, please leave a comment below. I'm sure that all the other threads on the case are fine. They're not really getting beat up like the threads. Like for this guy, this is not in some type of motion or type of torque or, well, torque when you bolt stuff down, but it's not being moved back and forth. So I wouldn't be concerned about this. Same thing for your fuel pump here. That's another one. I mean, it's not being moved a lot. It's not like the case is taking a beating. This area is not taking a beating. So these are usually fine, but I would recommend that you just run a nut through all of these to make sure that the threads are clear. One thing you don't want to find out that you snap one of these and then you gotta, I don't know, you gotta come drill. And like I said, helical or bushing, it don't matter. But definitely go through all these, especially on your oil pump. Here, you want to check these too. It'd be a pain to put your oil pump on and then come to find out that you snap this or the threads are screwed up. So, anyway, that's pretty it. Please leave a comment, like I said before, and thank you for watching.